As you close your eyes and start to relax, imagine yourself floating through space, calm, quiet, and endless. In this peaceful journey, we'll gently explore the biggest mysteries of the universe. These are questions no one has answered yet, like what came before the Big Bang, or if we're truly alone out there. There's no need to solve anything. Just listen, wonder, and let your mind drift. The stars are full of secrets, and tonight, we'll visit them one by one as you slowly fall asleep. 1. What came before the Big Bang? Close your eyes and picture the beginning of everything, not just stars or galaxies, but time itself. Scientists tell us the universe started with the Big Bang, an unimaginably powerful event that created space, time, matter, and energy. But what about before that moment? That's one of the most haunting questions in all of science. What came before the beginning? The strange truth is, no one really knows. According to Einstein's theories, time and space were born together in the Big Bang. That means before might not even exist the way we understand it. It could be like asking what's north of the North Pole. There simply is no before because time hadn't started yet. But some scientists wonder if our universe is part of something bigger, a cycle of endless births and deaths, with one universe collapsing and another springing to life. Others suggest a vast, timeless ocean of energy may have existed, from which our universe randomly emerged. There are even theories of multiple universes, each bubbling into existence like soap bubbles in the dark. It's a mystery wrapped in silence. A moment we can't see, can't touch, and may never fully understand. And yet, it stirs something deep in us, a quiet curiosity, a longing to know where it all began. As you fall asleep tonight, let your mind drift through that mysterious silence before time. Not to solve it, but to feel its wonder. To float peacefully in the quiet just before the first spark of everything. 2. What is dark matter made of? All around you, within the night sky, between the stars, and even through your own body, there's something invisible moving silently. It has no color, no light, no heat. We can't touch it, but we know it's there. Scientists call it dark matter, and though it makes up more than 80% of all the matter in the universe, no one knows what it actually is. Dark matter doesn't shine. It doesn't glow. It doesn't reflect light or absorb it. That's why we can't see it directly. But we know it exists because of how it pulls on things. Galaxies spin too fast to hold themselves together with just the matter we can see. Without dark matter, they would fly apart. It's like watching leaves swirl around an invisible wind. You don't see the wind, but you know it's real. So, what could this strange substance be? Some scientists believe it's made of particles we haven't discovered yet, particles that barely interact with anything. Others think it might be tied to unknown forces, or maybe even an illusion caused by our limited understanding of gravity. There's something deeply humbling about knowing that most of the universe is made of something we can't explain. It reminds us how much mystery still lives in the quiet spaces between the stars. As you sink deeper into rest, imagine this invisible ocean of dark matter gently surrounding the galaxies, peaceful, silent, and waiting to be understood. 3. What is dark energy? Imagine the universe as a great balloon, expanding in every direction. You'd think over time that expansion would slow down, maybe even stop, because gravity should pull things back together. But here's the twist. Not only is the universe expanding, it's speeding up. Some hidden force, is pushing everything farther and farther apart. That mysterious force is called dark energy, and we have almost no idea what it is. Dark energy isn't like anything we've ever seen. It doesn't act like a particle. It's not a gas, or a field, or a substance we can touch. But whatever it is, it fills the entire universe, quietly accelerating its growth. Right now, scientists think dark energy makes up almost 70% of everything in existence. That's more than all the stars, planets, galaxies, black holes, and dark matter combined. Some believe it might be a property of space itself, that space naturally wants to stretch. Others wonder if it's connected to energy in the vacuum of space, or even signs of another universe pressing on ours from the outside. Every idea leads to more questions, like echoes fading into the dark. As you drift further into sleep, think of dark energy as the quiet breath of the universe, slowly exhaling the stars into deeper distance. It's a soft, invisible force guiding the rhythm of the cosmos. We don't know what it is yet, but maybe that mystery is what makes it so beautiful. 4. What is the true shape of the universe? When you look up at the night sky, it feels endless, stars scattered in every direction, stretching forever. But what if the universe isn't endless at all? What if it has a shape, a form so vast and strange we can't quite picture it? That's one of the biggest mysteries of all. What is the true shape of the universe? To us, space seems flat. Light travels in straight lines, and the laws of physics behave the same everywhere we look. But on the larger scales, space might curve like the surface of a balloon, or twist into something even more bizarre, like a saddle or a loop that wraps around itself. Some theories suggest the universe could be finite but unbounded, like walking in one direction on Earth and eventually ending up where you started. In this case, you could travel through space forever without ever reaching an edge. Scientists use powerful telescopes to measure ancient light left over from the Big Bang, hoping to find tiny clues in how it spreads and bends. But so far, the results aren't clear. The universe might be perfectly flat, or just slightly curved beyond what we can detect. Or maybe its shape is something completely outside our current imagination. As your eyes grow heavier, imagine floating through this cosmic shape, whatever it may be. There's no need to find the edge. Just let yourself drift along the curves of space itself, carried by a mystery too wide to see. 5. Are we alone in the universe? In all the vastness of space, with billions of stars and trillions of planets, one question echoes quietly through time. Are we truly alone? Earth is full of life, from the deepest oceans to the tallest mountains. But out there, in the dark between the stars, does life exist somewhere else? Maybe on a distant planet with purple skies and alien oceans. Or maybe, far away, there are civilizations older and wiser than ours, watching the stars the same way we do, wondering the very same thing. We've searched for signs. We've listened for strange radio signals and scanned the skies for patterns that don't belong to nature. So far, we've heard only silence. But that doesn't mean we're alone. Space is so big that even the nearest stars are light years away. Reaching them would take thousands of years with today's technology. So maybe the silence is just distance. Or maybe life is common, but intelligent life is rare or brief. Some scientists believe the building blocks of life are everywhere, scattered like seeds across the cosmos. Others think life needs very special conditions, and we might be the only place it ever happened. But until we find proof, one signal, one fossil, one whisper in the dark, we simply don't know. As you drift deeper into sleep, imagine the stars above not as empty, but alive with possibility. Maybe someone out there is asking the same question tonight. Maybe they're dreaming, just like you. 6. What happened during the first second of the universe? Try to picture the very first second of time, the very first moment the universe began to exist. It wasn't quiet. It wasn't still. In that 1 second, everything changed. The universe expanded faster than the speed of light. Temperatures were trillions of degrees. Particles burst into existence, collided, vanished, and reappeared. Space itself stretched beyond anything we can truly imagine. But what actually happened during that first second? That's one of the greatest unknowns in all of science. We know the universe began with the Big Bang, and we've studied the light left behind from that explosion, the cosmic microwave background. But that light only shows what happened a little after the first second. The earliest fraction of a second, the first instant, remains hidden behind a veil of mystery. In that moment, the 4 forces of nature may have been one: gravity, electromagnetism, and the 2 nuclear forces woven together into something we've never seen. As the universe cooled, those forces split apart. Matter was born from pure energy. Tiny differences formed in the chaos, ripples that would one day grow into galaxies. But we still don't know how it began. Was there a spark? A trigger? A reason? Or did it all just happen? As you lie still tonight, think of that first second as a great cosmic breath, hot, fast, and full of potential. From that moment came everything you know. And yet, it remains the quietest, deepest secret the universe has ever kept. 7. What is the fate of the universe? Everything that begins must end. And the universe, though vast beyond imagining, may not be an exception. One of the deepest mysteries in all of space is what lies ahead. Will the universe expand forever? Will it slow down and collapse? Or will something stranger happen, something we can barely understand? Right now, we know the universe is expanding, and not just expanding, it's speeding up. Galaxies are drifting farther and farther apart. Stars are burning out. New ones are being born more slowly. Over trillions of years, the night sky may grow darker, colder, quieter. Some scientists call this the Big Freeze, where the universe becomes so stretched and empty that nothing new can happen. Just silence and cold. Others wonder if dark energy will keep growing stronger, tearing galaxies, stars, and eventually atoms apart in a violent end known as the Big Rip. Then there's the Big Crunch, a theory where gravity eventually wins, pulling everything back together into a single, hot point, perhaps ready to explode again in a new Big Bang. No one knows for sure. We're too early in the story to see how it ends. And yet, the question whispers through the stars, where is all of this going? As you drift deeper into rest, imagine the universe not as a fixed place, but as a living thing with a future still unwritten. We are part of that story. For now, rest easy in the quiet mystery of what comes next. 8. Are there parallel universes? What if this isn't the only universe? What if, just beyond the edge of what we can see, there are other realities, countless other versions of existence, each with its own stars, its own galaxies, its own rules? This is the strange and beautiful idea of parallel universes, also called the multiverse. Some scientists believe these other universes could be real. Maybe they were born alongside ours in a great cosmic sea, each bubble floating in its own space. Maybe they come from quantum possibilities, every decision, every chance, creating a new universe with a different outcome. In one, you might live a completely different life. In another, Earth might never have formed at all. These aren't just fantasies, they arise from serious theories in physics, like string theory and cosmic inflation. And while we can't see these other universes, some wonder if their shadows might affect our own. Tiny ripples in the fabric of space, unexplained cold spots in the sky, hints, perhaps, of something beyond the veil. But how could we ever reach them? Or even prove they are real? That's the mystery. If parallel universes exist, they may be forever out of reach, close in theory, but light years away in space and logic. As you slip deeper into sleep, imagine a hallway of endless doors, each one opening to a different version of everything. A universe where stars shine blue, where gravity floats upward, where time runs backwards. Endless possibilities, just a dream away. 9. What is inside a black hole? Imagine a place where gravity is so strong, nothing, not even light, can escape. A place where the very laws of physics break down. That's a black hole. And at its heart lies a mystery so strange, it defies everything we understand about space, time, and matter. Black holes form when massive stars collapse at the end of their lives. Their core shrinks into an incredibly small, incredibly dense point called a singularity. It's a spot where all the mass is crushed into zero volume, an idea that sounds impossible, but math says it must be true. Surrounding this core is the event horizon, the invisible boundary. Once something crosses that line, it's gone. Forever. But what really lies inside? Some scientists believe the singularity is real, a place of infinite density where time itself stops. Others think it's a puzzle we haven't solved yet, and that new physics, beyond what we know, might explain it. Some theories even suggest that black holes could lead to other universes or act like cosmic bridges, though we have no way of knowing. What makes this mystery even stranger is that black holes might not keep everything they swallow. Recent ideas suggest they could evaporate slowly over time, leaking information back into space. But how? And where does that information go? As you drift into dreams, imagine falling not into darkness, but into the unknown, a quiet, weightless place beyond sight and sound. What lies within the black hole is one of the universe's most closely kept secrets, waiting patiently to be understood. 10. Do white holes exist? If black holes are the ultimate cosmic trapdoors, pulling everything inward, never letting anything escape, then white holes are their mysterious opposite. A white hole is a theoretical object that does the reverse. Nothing can go in, and everything is pushed out. Time flows backward. Matter spills out instead of being swallowed. But do these strange, glowing fountains of the universe actually exist? White holes were first predicted by the same math that gave us black holes. If space-time could fold into a pit, it might also open into a peak. Some scientists believe a white hole might even be what you'd find on the other end of a black hole, connected through a hidden tunnel called a wormhole. Matter sucked into a black hole could be ejected through a white hole somewhere else in space, or even another universe. But there's a problem: we've never seen one. No object behaves exactly the way a white hole should. And many theories say white holes would be unstable. They disappear almost instantly, like a spark in the dark. Still, the idea fascinates scientists, because if white holes exist, they could help us solve deep mysteries about time, space, and what happens to matter inside a black hole. As you settle deeper into sleep, imagine a gateway in the stars, a place where time rushes outward, light escapes freely, and new beginnings are born from old endings. Whether real or just a dream of the cosmos, white holes invite us to wonder what lies on the other side of forever. 11. What causes fast radio bursts? In the stillness of space, far beyond our galaxy, strange signals sometimes flash for just a moment. Bright, sharp bursts of radio waves that come and go in the blink of an eye. These are known as fast radio bursts, or FRBs. They last only milliseconds, yet release more energy than the sun does in an entire day. They arrive without warning. They come from all directions. And we still don't know exactly what causes them. The first FRB was discovered in 2007, hidden in old telescope data. Since then, astronomers have found hundreds more. Some happen only once, others repeat again and again. But they don't seem to follow any pattern we can fully understand. They are so brief and come from so far away that tracking them is like trying to catch a single raindrop in the middle of a thunderstorm. Many ideas have been proposed. Some scientists think they could be caused by neutron stars, extremely dense remnants of collapsed stars, with magnetic fields so intense they snap and crack like giant cosmic whips. Others think they might be collisions between stars, or even echoes of ancient black holes being born. And of course, there's always the wonder: could they be signals from intelligent life? Beacons? Messages? We don't know. Not yet. As your body grows still and your breath slows, imagine the soft night of space pulsing with distant flashes, cosmic whispers that no one can explain. Brief, bright, and mysterious, these bursts are like the universe speaking in code, waiting patiently for us to listen. 12. What is the Great Attractor? Far across the cosmic sky, galaxies are not just sitting still, they are moving. Our own Milky Way, along with countless other galaxies, is drifting through space at over 1 million miles per hour. But here's the strange part: we're not moving randomly. We're being pulled, tugged, slowly but surely, towards something scientists call the Great Attractor. This mysterious force lies about 150 million light-years away, in a patch of sky so crowded with stars, dust, and galaxies that we can barely see into it. Yet we know it's there, because we can feel its pull. Entire clusters of galaxies, spanning hundreds of millions of light-years, are all being drawn toward this hidden region of space. But what is it? That's the mystery. Some scientists believe it's a massive concentration of galaxies and dark matter, heavier than anything we've ever seen. Others think it could be part of an even larger structure, something we call the Shapley supercluster, a giant wall of galaxies bending the fabric of space itself. And then there are more curious ideas. Could it be a sign of something beyond our observable universe? A distant, unseen realm pulling from the other side? The truth is, we're still trying to peer through the cosmic fog. The great attractor lies in the so-called zone of avoidance, where thick dust in our galaxy blocks much of the view. It's like trying to spot a lighthouse through a storm. As you drift deeper into sleep, imagine this invisible giant, far away in the dark, slowly calling the stars home. 13. Why is the universe's expansion accelerating? Long ago, scientists thought the universe's expansion would eventually slow down. After all, gravity pulls things together. So it made sense to think that over time, galaxies would gradually stop moving apart, maybe even collapse back in. But in 1998, something astonishing was discovered. The universe isn't slowing down, it's speeding up. Galaxies aren't just drifting away, they're rushing faster and faster into the void. It's as if the universe has hit the gas pedal, and no one knows why. This strange acceleration changed everything. It led to the idea of dark energy, a mysterious force pushing the universe apart. We can't see it, touch it, or measure it directly, but it seems to make up nearly 70% of the entire cosmos. It's everywhere, filling every inch of empty space, quietly pulling the stars farther and farther from each other. But why is it happening? Is dark energy a new kind of energy? Is it just how space works? Or could it be something even stranger, like the influence of other dimensions, or the shape of the universe stretching in ways we can't yet understand? The deeper we look into space, the more the mystery grows. It's as if the universe is expanding into some greater unknown. As your thoughts grow quiet, imagine the galaxies drifting apart like glowing lanterns in a vast sea, each one floating gently away into silence. There's no rush to understand. Just let your mind rest in the steady breath of the universe, forever unfolding. 14. What exactly is time? We live our whole lives inside of it. Every second that passes, every heartbeat, every sunrise, and every dream happens in the flow of time. But what is time, really? Is it a thing? A direction? A feeling? This is one of the most puzzling questions in both science and philosophy, and we still don't fully understand the answer. Time feels simple. It moves forward. The past is behind us, the future ahead. But the laws of physics tell a stranger story. In equations, time doesn't need to move forward at all. The math works just as well backward. So why do we experience time one way, like pages turning in a book we can never reread? Some say time is tied to entropy, the way disorder increases over time. An egg breaks, but never unbreaks. Ice melts, but doesn't refreeze on its own. That rise in disorder may be what gives time its arrow. Others wonder if time is an illusion, just a human way of organizing change. In deep space, near black holes, time actually slows down. It stretches, bends, pauses. So is time something real, or just how we perceive the universe unfolding? We measure it with clocks, but we feel it with memories, with moments, with the way life moves and never stops. As you begin to drift off, imagine time not as a ticking clock, but as a gentle river, flowing around stars, planets, and dreams, never quite the same twice, and never truly understood. 15. How big is the universe? When you gaze up at the stars, it feels endless. But is it? How big is the universe, really? The answer is, we don't know. And maybe, we never will. The part of the universe we can see is called the observable universe. It stretches about 93 billion light-years across. That means light from the farthest edges has been traveling toward us for over 13 billion years. But the universe has been expanding that whole time, stretching space itself. So the edge is now much farther than that first light could have reached. It's like watching a lighthouse from a moving ship. You see the light, but the source keeps drifting farther away. And here's the mind-bending part. Beyond that observable bubble, space might continue forever. There could be galaxies, stars, and even entire regions of space we will never see, not because they don't exist, but because their light will never reach us. They are, quite literally, beyond time. Some scientists think the universe might wrap around itself, looping in on all sides. Others think it goes on infinitely, no boundaries, no edge, just stars, dust, and silence forever. As you drift into sleep, let your mind float beyond the stars, past the galaxies, beyond the edges of light itself. Don't worry about how far it goes. Just imagine the universe stretching endlessly, like a soft blanket of stars, surrounding you in calm and wonder. 16. Is the multiverse real? Imagine for a moment that this universe, our universe, with its stars, planets, and galaxies, is just one of many. Not the center. Not the only story. Just a single page in a book with infinite pages. This is the idea behind the multiverse, a concept so vast, it reshapes the way we think about reality itself. There are many versions of the multiverse theory, each stranger than the last. One suggests that during the Big Bang, not just one universe was created, but countless others. Like bubbles in a never-ending sea of creation, each with its own version of physics, time, and even life. Some might be similar to ours, others unimaginably different. Another idea comes from quantum physics. Every time a decision is made, even the tiniest one, like blinking your eyes or flipping a coin, the universe splits, creating two new realities. One where it happened, one where it didn't. If that's true, there may be infinite versions of you, living infinite lives, in infinite worlds. But is any of it real? We don't know. There's no proof, no telescope that can peer beyond the edges of our universe to find another. And yet, the math says it's possible. The silence of space leaves room for wonder. As you fall deeper into sleep, imagine those other universes softly spinning beside ours, unseen and untouched, like dreams beyond dreams. You're not just part of a universe, you may be part of something far greater, stitched into the quiet fabric of forever. 17. What is the origin of cosmic rays? Every second, invisible particles called cosmic rays pass through your body. They come from space, tiny, high-energy messengers, faster than anything we can build on Earth. But where do they come from? What launches them across the universe at nearly the speed of light? That's a question we're still trying to answer. Cosmic rays aren't rays like beams of light, they are particles, often protons or atomic nuclei, moving with unimaginable speed. Some are born in our sun, some in nearby stars, but the most powerful ones, called ultra-high-energy cosmic rays, seem to come from far beyond our galaxy. These particles have so much energy that they crash into Earth's atmosphere like tiny bullets, creating showers of other particles that rain down silently. What could launch something with that much power? Maybe exploding stars, called supernovae. Maybe jets from black holes or spinning neutron stars. Some even wonder if they come from outside our known universe, from forces or places we've never seen. But here's the tricky part. Cosmic rays don't travel in straight lines. They are bent and twisted by magnetic fields as they move through space. By the time they reach Earth, we can't easily tell where they came from. They arrive as a mystery, wrapped in energy and silence. As your body relaxes, imagine space filled with these invisible travelers, tiny whispers of distant chaos, crossing the void to reach you. They are ancient, fast, and mysterious, and the universe still hasn't told us why they fly. 18. What is dark flow? In the vast stillness of space, most galaxies are drifting away from each other as the universe expands. It's a smooth, gentle motion, like a calm tide spreading across the cosmos. But something strange has been observed, an odd movement that doesn't fit the pattern. It's called dark flow, and it's one of the most mysterious discoveries in modern astronomy. Scientists noticed that a group of galaxy clusters, billions of light-years away, are all moving in the same direction, as if something massive, something far beyond what we can see, is pulling them. This movement doesn't match the normal flow of cosmic expansion. It's as if these clusters are being tugged by an invisible force, coming from a place beyond the edge of the known universe. But what could cause this? Some believe it might be a concentration of mass, perhaps a huge region of dark matter or something stranger still, lying far beyond our cosmic horizon. Others think it could be a sign of another universe brushing against ours, like a silent ripple from another reality. There's even a chance it's a flaw in our data, but so far, no simple explanation fits. What makes dark flow so haunting is that it hints at something outside the universe we can see. A hidden motion in the deep fabric of space. As you fall deeper into sleep, imagine these galaxy clusters drifting, drawn by an unseen hand. Quietly moving, slowly pulled, not by gravity alone, but by a secret the universe hasn't yet shared. 19. What lies beyond the observable universe? Look out into the night sky. Every star, every galaxy, every beam of light you see, it's all part of what we call the observable universe. It stretches roughly 46 billion light-years in every direction. That's how far light has traveled since the Big Bang, and it's the limit of what we can observe. But what lies beyond that edge? That's a question we may never fully answer. Beyond the observable universe, space may simply continue, forever. Billions more galaxies, stars, and worlds might be out there, just too far for their light to have reached us yet. The universe could be infinite, with no edge, no boundary, just endless silence. Or, things could be very different. Some theories suggest that beyond our horizon, the universe might change. The laws of physics might shift. Time might flow differently. There might even be pockets of space where entire alternate universes exist, sealed off from our own. Places we can't see, touch, or reach, but that may exist just the same. Because we're inside the universe, we can only look so far. Beyond that, it's like staring into a fog that never clears. We know there's something out there. But what? That's the mystery. As you settle into sleep, imagine standing at the edge of what's known, gazing out into the infinite unknown. Beyond that cosmic curtain, more wonders await, forever hidden, but softly whispering that there's always more to discover. 20. What are quasars? Far away in the deepest parts of the universe, there are objects so bright they can outshine entire galaxies. And yet, they are not stars. These blazing beacons are called quasars, and they are among the most powerful and mysterious objects in existence. A quasar looks like a star from far away, but it's something much stranger. At the center of most galaxies lies a supermassive black hole, millions or even billions of times heavier than the Sun. When gas and dust fall toward it, they don't just disappear. Instead, they swirl around in a glowing disk, heating up to incredible temperatures. The result is a quasar, a blinding light, brighter than 100 galaxies combined, powered by a black hole feeding hungrily on matter. Quasars can shoot out jets of energy that stretch across millions of light-years. Some flicker like cosmic lighthouses. Others seem to flash and fade, pulsing through the darkness of deep time. We know they come from the early universe. Many of the quasars we see today are billions of years old. Their light has been traveling to us since before Earth even formed. But why were they more common long ago? And why do they burn so brightly, only to go quiet later? We're still trying to understand. As you drift deeper into sleep, picture a quasar shining like a brilliant eye in the center of a galaxy, casting its light across the ages. A fire in the void, born from hunger and gravity, burning far away, but never forgotten. 21. How do supermassive black holes form? At the center of nearly every galaxy, including our own, lurks a giant. A supermassive black hole, millions or even billions of times more massive than the Sun. These cosmic beasts are invisible, yet their influence shapes entire galaxies. They hold stars in orbit. They power quasars. They bend time itself. But how did they get there? That remains one of the universe's most puzzling secrets. We know how small black holes form, from the death of massive stars. But supermassive black holes are too big, too early. We found them in the ancient universe, just a few 100 million years after the Big Bang. That's barely enough time for stars to even form, let alone die and collapse into something so huge. Some scientists think these giants started from special seed black holes, formed when clouds of gas collapsed directly, skipping the star stage altogether. Others believe they grew rapidly by merging with each other or swallowing enormous amounts of matter in a short time. But even then, how did they get so big, so fast? There's also a chance that something new, something we don't yet understand, helped them grow. Exotic physics, hidden forces, or conditions in the early universe that no longer exist. As you drift further into rest, imagine a young galaxy forming in the dark. At its heart, a black hole begins to grow, silently feeding, shaping stars and space. A mystery buried deep in time, waiting for us to look close enough to understand. 22. What is the nature of singularities? At the center of every black hole lies a point where the laws of physics collapse into silence. This point is called a singularity. It's a place of infinite density, where gravity is so strong that space and time twist in on themselves. But what is a singularity, really? Is it a physical object, or just a sign that we've reached the edge of our understanding? According to Einstein's equations, once matter collapses into a black hole, it keeps compressing until it reaches an infinitely small point. But infinity in science usually means, we don't know yet. Maybe singularities don't actually exist. Maybe, at some deeper level, nature has a hidden law that prevents them. Some physicists think singularities are just the universe's way of telling us our current theories aren't enough. To truly understand them, we might need a new theory, something that combines quantum mechanics with gravity. Something like a theory of everything. Until then, the singularity remains a mystery wrapped inside a black hole, sealed off from the rest of the universe, unreachable, unknowable, and strangely peaceful. As you relax into sleep, imagine a point so small it holds the weight of stars, a place where time has no meaning and silence is absolute. 23. What causes gamma-ray bursts? In the quiet darkness of space, sometimes the most powerful explosions in the universe flash for just a second. These are gamma-ray bursts, and they shine brighter than entire galaxies, then vanish. No warning. No echo. Just a flash of pure energy and silence. Gamma-ray bursts are so intense that if one went off too close to Earth, it could wipe out our planet's atmosphere. Thankfully, the ones we've observed are from galaxies far away, so distant, in fact, that their light has traveled billions of years to reach us. What causes them? Some seem to come from the deaths of giant stars collapsing into black holes. Others may be caused by the merging of two neutron stars, dense, dead cores of exploded stars. These mergers are so violent they ripple space itself. And yet, not all gamma-ray bursts fit neatly into those explanations. Some are short. Some are long. Some appear without any known source. Are there other causes we haven't discovered yet? Could something even more exotic, like dark matter collisions or unknown cosmic engines, be creating them? As your mind floats deeper into rest, imagine the flicker of a gamma-ray burst on the far side of the universe, a flash of light older than Earth itself. Brief, brilliant, and still unsolved. 24. Are wormholes real? Imagine folding a piece of paper so two distant points touch. That's the idea of a wormhole, a shortcut through space and time. If they exist, they could connect one side of the universe to another, or even different universes entirely. The theory of wormholes comes from Einstein's equations, which suggest that under the right conditions, space-time could be warped to form tunnels. These tunnels might let you travel vast distances instantly, skipping the endless wait of light-speed travel. Some even wonder if wormholes could allow for time travel, moving not just through space, but through past and future. But here's the problem, we've never seen one. They're incredibly unstable. If a wormhole did form, it might collapse before anything could pass through it. Scientists believe it would take something called exotic matter, with negative energy, to hold one open. Exotic matter isn't impossible, but we haven't yet found a way to create it or prove it exists. Still, the idea of wormholes lingers, like a beautiful myth born from math. They remind us that the universe might be far more flexible and far more strange than we ever imagined. As you drift off, picture two stars linked by a silent tunnel, hidden in space like a secret doorway. Not just science fiction, but a real possibility waiting in the folds of the cosmos. 25. What is the true nature of gravity? Gravity is the most familiar force in the universe. It keeps our feet on the ground, holds the moon in orbit, and shapes the motion of galaxies. Yet, for all its power, gravity remains one of the least understood forces in nature. What is it, really? Isaac Newton described gravity as a force that pulls objects toward one another. Albert Einstein later transformed that idea, showing that gravity is the warping of space and time by mass, planets and stars bending the very fabric of the cosmos. But even Einstein's elegant theory might not be the full story. Gravity doesn't fit neatly with quantum physics, the theory that explains the tiniest parts of the universe. All the other forces, like electromagnetism, have quantum particles that carry them. But gravity's messenger particle, the graviton, has never been found. Could gravity be a shadow of something deeper? An illusion? Or the echo of another dimension? Some scientists believe gravity might leak into our universe from a hidden realm. Others think it's a result of the universe's geometry, a bending too subtle for us to detect. As you gently float into sleep, imagine gravity not as a pull, but as a soft curve in space itself, quietly guiding stars, galaxies, and dreams through the dark. 26. What is the source of the universe's magnetism? Magnetic fields are everywhere in the universe. The Earth has one. The Sun does, too. Galaxies have magnetic fields that stretch across hundreds of thousands of light years. Even the space between galaxies seems to hold a faint magnetic whisper. But no one really knows how these cosmic magnetic fields first came to be. We understand how magnetic fields work now, how they shape solar winds, guide particles, and form the beautiful glow of auroras on Earth. But what started it all? Where did the very first magnetic fields come from? Were they created during the Big Bang? Or did they arise later, as stars and galaxies formed? Some scientists think tiny magnetic seeds were born in the early universe, perhaps through random quantum fluctuations. Over billions of years, these seeds could have been stretched, twisted, and amplified by cosmic motion. Others believe there may be a hidden force or unknown particle that helps generate magnetism on vast scales. And yet, it remains a quiet mystery, woven into the fabric of the universe, felt but not fully seen. As you drift further into sleep, picture invisible lines curling through space, gentle currents guiding the dance of galaxies, always present, always mysterious. 27. Why is there more matter than antimatter? At the moment of the Big Bang, matter and antimatter were created in equal amounts. For every particle of matter, there should have been a twin made of antimatter, with the same mass but opposite charge. And when matter and antimatter meet, they destroy each other in a flash of energy. So here's the puzzle. If they were equal, why is there anything left? Why are we here? Where did all the antimatter go? Somehow, matter won. For reasons we still don't fully understand, a tiny imbalance occurred. Just enough extra matter survived after all the annihilations. That tiny leftover became the stars, the planets, the oceans, and you. Scientists have spent decades trying to solve this mystery. They've looked for differences between matter and antimatter in particle experiments. Some clues suggest antimatter decays slightly differently, but the answers are still blurry. This one tiny difference between matter and antimatter is the reason the universe isn't just an empty sea of light. As you sink into deeper rest, imagine the beginning of everything, a flash of equal light and shadow, and a quiet tilt that gave us the stars. A small imbalance that became the story of everything. 28. What is the shape of space-time itself? Space-time is not just a background. It's not a quiet stage where the universe performs. It is the universe, the invisible fabric that holds space and time together, bending and stretching with every star, every planet, and every breath of motion. But what shape does this fabric truly have? Einstein showed that space-time bends around mass, like a blanket sinking beneath a heavy ball. That's what creates gravity. But on the larger scales, beyond galaxies and clusters, what is the overall shape of space-time? Is it flat and endless? Curved like a giant sphere? Or shaped like a saddle, opening outward forever? The shape of space-time affects everything, from how light travels to how the universe will end. Observations suggest our universe is nearly flat, with only the tiniest curve. But that doesn't rule out more complex shapes. Space could be folded into loops, or twisted in extra dimensions we can't detect. There's also the idea of topology, the study of how space can be connected. Maybe the universe wraps around on itself. Maybe if you traveled far enough in one direction, you'd return from the other, like walking around the surface of a globe. Yet we can only see so far. The true shape of space-time might lie beyond what light has reached us. As you drift off to sleep, imagine floating through an invisible ocean of curves and folds, space itself, alive and changing, shaped by stars and mysteries still waiting to be seen. 29. What is vacuum energy? Even in the deepest, darkest parts of space, far from stars, planets, and galaxies, there is no such thing as true emptiness. What seems like a perfect vacuum is actually teeming with invisible energy. This is known as vacuum energy, and it may hold the key to understanding the very structure of reality. Quantum physics tells us that even empty space is alive with activity. Tiny particles and antiparticles constantly flicker into existence, then vanish, too fast to be seen. This restless motion creates energy, even where there appears to be nothing. And this energy isn't just a background detail, it might be responsible for the acceleration of the universe itself. Some scientists think vacuum energy and dark energy could be the same thing. If so, it would mean that this invisible energy fills the entire cosmos, pushing galaxies apart like a slow, invisible wind. But there's a problem. When scientists try to calculate the amount of vacuum energy predicted by quantum theory, the numbers come out absurdly large. Far bigger than what we observe. So either we're missing something major, or our understanding of space is still incomplete. As you drift deeper into sleep, imagine the quiet spaces between stars not as empty, but alive, buzzing softly with hidden energy. A silent sea of motion beneath all things. Vacuum energy is the hum beneath reality, too faint for us to hear, but always there. 30. What is the cause of the cosmic microwave background cold spot? The cosmic microwave background, CMB, is the oldest light in the universe. It's the afterglow of the Big Bang, faint, cool radiation that fills all of space like a soft echo of creation. But hidden in this glow is a strange feature that still puzzles scientists, the cold spot. Most of the CMB is remarkably uniform, with only tiny temperature differences across the sky. But one region stands out. It's colder than the rest by a significant amount. Not just a little colder, but oddly so. It's a dark patch in the ancient light, stretching across a huge section of space, and no one knows exactly why it's there. Some think it might be caused by a vast region of empty space, a supervoid, with fewer galaxies and less matter. Light passing through this emptier region might lose a bit of energy, making the spot look colder. But even this idea doesn't fully explain the size and depth of the cold spot. Others wonder if the cold spot could be something much stranger, a sign of another universe brushing against our own in the early moments of time. A cosmic bruise left behind from a deeper collision. Whatever it is, it's one of the most eerie and intriguing fingerprints left on the sky. As you sink deeper into sleep, picture a shadow in the oldest light, a quiet question glowing softly above us, unchanged for billions of years, and still waiting for an answer. 31. What are strangelets? In the heart of collapsed stars, matter is crushed into exotic forms. One of the most mysterious is something called a strangelet, a hypothetical particle made not just of the usual up and down quarks, but also of strange quarks. It may sound like science fiction, but it's taken very seriously by physicists. Normal matter, like protons and neutrons, is made of up and down quarks. But under extreme pressure, like in a neutron star, some theorists believe these quarks could merge into a strange new form. This strange matter might be incredibly stable, and if it is, it could spread. If a strangelet touches regular matter, it could transform it, one atom at a time, into more strange matter. It's a chilling idea. A single strangelet could, in theory, turn an entire planet into a dense, featureless mass in seconds. But don't worry, there's no evidence it's ever happened, and particle accelerators haven't found any yet. Still, strangelets could explain certain cosmic mysteries, like unusual signals from distant stars or strange flashes of radiation. If they exist, they might even be a part of dark matter, silently drifting through the galaxy. As your body relaxes into rest, imagine strangelets as tiny seeds of transformation, drifting through the void, silent, invisible, and full of cosmic potential. Whether dangerous or simply misunderstood, they remain one of the strangest what-ifs in all of astrophysics. 32. Are there stars made of dark matter? We know stars as burning spheres of gas, mostly hydrogen and helium, fusing atoms in their cores to shine for billions of years. But what if there's another kind of star? One not made of normal matter, but something invisible and strange, dark matter. Could dark stars really exist? Dark matter doesn't emit light or heat. We can't see it, but we know it's there, surrounding galaxies, shaping their movements, making up most of the mass in the universe. And yet, we don't know what it's made of. But in the early universe, when everything was new and thick with particles, some scientists think dark matter may have gathered into clouds, and then into stars. These dark stars wouldn't shine like ours. Instead of using nuclear fusion, they might be powered by dark matter particles colliding and annihilating inside, releasing bursts of energy. Imagine a star that glows not because it's burning, but because invisible particles are vanishing within it. If dark stars ever existed, they may have lived in the early universe and then faded, leaving little trace behind. Or maybe, just maybe, some still exist in far-off galaxies, invisible to our telescopes, glowing faintly with a kind of light we cannot yet detect. As you drift deeper into rest, picture a star made of silence and shadow, burning without fire, hidden in the dark, a quiet reminder that the universe may still be hiding entire classes of stars we've never truly seen. 33. What are blazars, and why are they so powerful? Deep in space, there are galaxies with black holes so active, they become cosmic powerhouses. These galaxies are called blazars, and they are among the brightest, most energetic objects in the universe. But what makes a blazar different from a normal galaxy or even a quasar? At the heart of every blazar is a supermassive black hole. As matter spirals inward, it forms a swirling disk that heats up and glows brilliantly. But what makes blazars special is their jet, an enormous beam of high-energy particles shooting out from the black hole's poles at nearly the speed of light. And in a blazar, one of these jets is pointed almost directly at Earth. It's like staring into the barrel of a cosmic cannon. These jets produce intense radiation across the entire spectrum, from radio waves to gamma rays. Sometimes, a blazar can suddenly flare, becoming 1,000 times brighter in moments. We've seen them blink, flash, and pulse as if alive, even from billions of light years away. But we still don't fully understand how these jets form or why they are so powerful. What controls them? What decides when they flare? As your thoughts soften, imagine a distant galaxy with a heart of fire and shadow, sending a beam of ancient light across the universe. Blazars are lighthouses from the deep, reminding us that even the darkest places can shine with ferocious, mysterious energy. 34. Is time travel possible? Time travel has captured the human imagination for centuries. Stories of jumping into the past or leaping into the future appear in myths, science fiction, and scientific theories alike. But could it ever really happen? Could we travel through time the way we travel through space? In a way, we already do. Every second, we're moving forward in time. And Einstein's theory of relativity shows that time can slow down under the right conditions. The faster you move, the slower time passes for you. If you orbited a black hole or traveled near the speed of light, time would tick differently for you than for someone back on Earth. This is called time dilation, and it's been confirmed by real experiments. But traveling backward in time? That's a different story. Some solutions to Einstein's equations allow for closed time-like curves, loops in space-time where time could, in theory, bend back on itself. Wormholes might allow shortcuts to the past or future. But these ideas require exotic materials, negative energy, and conditions we've never created. There's also the famous paradox. If you went back in time and changed something, would you erase your own future? So far, time travel remains a dream. Possible in theory, impossible in practice. But the door isn't fully closed. As your mind slows down for the night, imagine drifting through a river where time flows like water, sometimes fast, sometimes slow, and maybe, just maybe, ready to turn back. 35. What are magnetars? In the quiet aftermath of a massive star's death, something extraordinary can be born. Not just a neutron star, not just a black hole, but something even stranger, a magnetar. It's one of the most magnetic objects in the entire universe, and its power is almost beyond imagination. A magnetar is a type of neutron star, a dense core left behind after a star explodes in a supernova. It's incredibly small, about the size of a city, but contains more mass than the Sun. What makes a magnetar special is its magnetic field. It's 1,000 times stronger than that of a typical neutron star and trillions of times stronger than Earth's. If a magnetar were as close to Earth as the Moon, it could wipe your credit cards and erase your brain's chemistry just with its magnetic force. These extreme fields can twist and snap, triggering powerful bursts of radiation, gamma rays and X-rays that light up the sky like a flare from the depths of space. Some of the brightest flashes we've ever seen came from magnetars. But we don't fully understand them. Why do only some stars become magnetars? How long do their magnetic fields last? And could their violent outbursts explain some of the mysterious fast radio bursts we detect? As you drift deeper into rest, imagine a star no bigger than a city, pulsing in silence, wrapped in invisible force. Magnetars are cosmic giants hiding in plain sight, born from death and burning with hidden power. 36. Could alien megastructures exist? Across the universe, stars shine with steady light. But now and then, we find one that flickers oddly, dimming in ways that seem unnatural. In 2015, scientists spotted a star called KIC 8462852, nicknamed Tabby Star, that was dimming unpredictably. Some wondered, could it be caused by something extraordinary? Something built? The idea of an alien megastructure, a vast technological object built by an advanced civilization, has long been part of science fiction. One famous concept is the Dyson sphere, a massive shell or swarm of satellites surrounding a star to capture its energy. If a civilization were truly advanced, it might need more power than a planet can offer. So why not harvest the star itself? When Tabby's star dimmed, people speculated, could we be seeing a Dyson-like structure? Maybe huge solar collectors or a massive orbiting machine blocking the light. Scientists quickly searched for signs of radio signals or heat, anything to suggest intelligence, but found nothing conclusive. More likely, the dimming is due to clouds of dust or swarms of comets. But the mystery hasn't been fully solved. And it raises a question that still echoes in the quiet. If intelligent life exists elsewhere, could it reshape stars? Could their greatest machines be visible from light years away? As you ease into dreams, imagine the soft flicker of a distant star, blinking through veils of mystery. Perhaps it's dust. Perhaps it's design. The universe leaves room for wonder. 37. What is the fate of the universe? Will the universe expand forever, or will it collapse? Will everything freeze in silence, or tear apart into nothingness? The fate of the universe is one of the biggest, most humbling mysteries we face, and it stretches far beyond our lifetimes. Right now, the universe is expanding. Galaxies are moving away from each other, and the space between them is growing larger. But this expansion is not slowing down, It's speeding up, driven by a mysterious force we call dark energy. What does that mean for the future? One possibility is the Big Freeze. As the universe expands endlessly, galaxies will drift farther apart. Stars will die, one by one, until the night sky goes dark. Over trillions of years, even atoms might decay, leaving a universe cold and empty. Another idea is the Big Rip. If dark energy keeps growing stronger, it could eventually tear apart galaxies, planets, atoms, everything. The universe would end in a violent rush, ripped from the inside out. Or, maybe, the universe will one day reverse, slowing down, collapsing inward into a final big crunch, where everything returns to the dense state from which it began. And from that, maybe, another beginning? We don't yet know. The math points in many directions, and the answers lie billions of years away. As you drift off, imagine the universe breathing, slowly expanding, gently fading, or waiting to be born again. Its fate is a story still unfolding, one written in the stars. 38. What is causing fast radio bursts? In the vast stillness of the cosmos, a strange sound echoes, brief, bright bursts of radio energy that last just milliseconds. These are fast radio bursts, or FRBs, and they come from galaxies billions of light-years away. What causes them? We're not sure. But they are one of the most electrifying mysteries in modern astronomy. First discovered in 2007, FRBs are incredibly powerful. In a fraction of a second, they release as much energy as the sun does in days. Some are one-time events, never seen again. Others repeat, flashing again and again, like a cosmic heartbeat. But their sources remain mysterious. Could they come from magnetars, those ultramagnetic neutron stars? That's one possibility. Their energy and unpredictability could explain some of the bursts. Or maybe it's something even stranger, colliding neutron stars, black holes, or flares from stars we don't yet understand. And then there's the most curious idea of all. Could some FRBs be signals, deliberate transmissions, sent by intelligent life far away? It's unlikely, but it lingers in the mind because these bursts come from such distant places, and we still don't know what produces them. We now have telescopes scanning the skies, catching FRBs in real time. Still, for every answer, more questions arise. As you gently slip into sleep, imagine the universe whispering across the darkness, flashes of unknown origin, messages from faraway galaxies, riding the silence like notes in a dream. Something is calling, and the stars are listening. 39. Do white holes exist? We've all heard of black holes, cosmic pits that devour anything that comes too close. But what about the opposite? What if, instead of pulling everything in, something in space only pushes out? This is the idea behind a mysterious concept called a white hole. A white hole is the theoretical reverse of a black hole. While a black hole pulls in matter and doesn't let anything escape, not even light, a white hole would constantly push matter out, never allowing anything to enter. In a sense, it would be like a cosmic fountain, spitting out energy and particles into the universe. So far, we've never seen one. But in theory, white holes could exist. Some scientists suggest that what falls into a black hole could be ejected through a white hole somewhere else, maybe even in another part of the universe, or another universe entirely. A kind of cosmic portal. Others think white holes might be short-lived phenomena, quickly collapsing or fading before we can detect them. Or perhaps they exist only in the realm of mathematics, not in reality. Still, the idea is beautiful, a mirror twin to the most destructive force we know, one that gives instead of takes. As you sink into deeper dreams, picture a gateway in space, light pouring outward, particles dancing in a stream of creation, and the universe gently balancing destruction with mystery. If black holes are endings, could white holes be beginnings? 40. What caused the Big Bang? The universe began with a bang, but what set it off? The Big Bang is the moment when time, space, and energy all burst into being. It marks the start of everything we know. But what caused it? That's a question that still echoes at the edge of understanding. According to science, about 13.8 billion years ago, all matter and energy were packed into an unimaginably hot, dense point. Then, in a flash, space itself began to expand. Galaxies formed. Stars lit up. Time moved forward. But what came before that moment? Some say the question doesn't even make sense, because time itself began with the Big Bang. Before that, there may have been no before. But others believe something must have triggered it. Perhaps a previous universe collapsed and sparked a new one, in a cycle that goes on forever. Or maybe quantum fluctuations in a timeless void randomly gave rise to our universe. There are even theories that suggest our universe is one of many, just a bubble in a vast multiverse, each bubble popping into existence with its own Big Bang. The truth remains hidden. We can look back close to the beginning, but not past it. As your breath softens, imagine the first heartbeat of the cosmos, quiet, sudden, brilliant. Not with noise, but with light. A beginning from nothing, or from something we still cannot name. 41. Could the universe be a simulation? What if everything around you, the stars, galaxies, even your thoughts, wasn't real in the way we think, but part of a giant simulation? It sounds like science fiction, but some serious thinkers believe it's a possibility. Could the universe itself be code running on an unimaginable computer? This idea, called the simulation hypothesis, suggests that a highly advanced civilization could create virtual worlds so detailed that the conscious beings inside wouldn't know they were simulated. If technology keeps advancing, it's possible we might someday create our own simulated universes. And if we can do it, what's to say it hasn't already been done? Some scientists have looked for clues, tiny glitches in reality, odd patterns in cosmic rays, or limits in how smooth the universe appears at its smallest scales. Others argue that if we were in a simulation, there would be mathematical fingerprints left behind, signs that our universe isn't continuous, but pixelated like a digital screen. But there's no solid evidence. It remains a fascinating thought experiment. If we are inside a simulation, how could we ever know? As you drift into a calm, reflective sleep, picture the universe not as endless matter and motion, but as light and logic. A quiet program running in the dark, rich with stars and stories. Whether real or simulated, it feels real to us, and maybe, in some deeper way, that's what matters most. 42. What are cosmic strings? Imagine thin, invisible threads stretching across the universe, remnants of creation itself. These are cosmic strings, theoretical objects believed to be thinner than an atom, yet incredibly dense. A single string a mile long could outweigh the Earth. If they exist, they may have been formed in the earliest moments after the Big Bang, like cracks in the cooling skin of the young universe. Cosmic strings are not like strings of matter or rope. They are topological defects, flaws in space-time itself. Think of how ice sometimes forms cracks as it freezes. Cosmic strings would be like those cracks, only on a cosmic scale, slicing through space and possibly stretching across galaxies. They could warp the space around them, bending light and even affecting time. Some scientists think we might detect them by looking for gravitational lensing, light from distant galaxies bent into strange shapes as it passes near a string. Others wonder if cosmic strings could produce gravitational waves, tiny ripples in the fabric of the cosmos. No direct evidence has been found yet. But if cosmic strings are real, they would be one of the oldest structures in existence, older than stars, galaxies, or atoms. As you drift further into rest, imagine delicate strands of space itself stretched across the void, silent and ancient. Cosmic strings are like the universe's forgotten scars, beautiful and hidden, whispering of a time before time. 43. What happens inside a black hole? We know that black holes are places where gravity becomes so strong that nothing, not even light, can escape. But what happens inside a black hole, beyond the event horizon? That remains one of the most haunting questions in all of science. Crossing the event horizon is like stepping off a cliff where the rules of physics start to break down. Space and time swap roles. You can't stop or turn back. You're pulled inward toward the center, the singularity, where gravity becomes infinite and the known laws of science seem to collapse. Some theories say that at the singularity, all matter is crushed to a point. Others suggest something more strange, that information, the very identity of what fell in, might be stored in a mysterious way on the surface of the black hole. This leads to the information paradox. How can information escape if nothing else can? Still others think black holes could be portals, connecting to white holes or even other universes. We just don't know. No signal can escape from inside, so we're left with equations, theories, and deep curiosity. As you gently drift into dreams, picture the edge of a black hole not as an ending, but as a question. A doorway into the unknown, where time falls inward and mystery deepens with every step. Inside lies the quiet center of gravity itself, a place where the universe holds its secrets the tightest. 44. Could the universe be conscious? What if the universe isn't just a collection of stars and space, but something with awareness? It sounds mystical, but some philosophers and scientists have seriously explored this question. Could the universe itself be conscious? Consciousness is one of the greatest mysteries of all. We don't fully understand how our own minds arise from the matter in our brains. So when we look out at the universe, a place filled with complexity, structure, and motion, it's natural to wonder, could consciousness emerge at a cosmic scale? One idea, called panpsychism, suggests that consciousness might be a fundamental feature of the universe, like space, time, or gravity. Every particle, every atom, could carry a flicker of awareness. And together, perhaps, they add up to something more. Maybe galaxies and networks of stars aren't just physical, they're also part of a vast, invisible mind. Others wonder if the universe has evolved to become aware of itself through us. After all, humans are made of star stuff. We are the universe, thinking about the universe. Of course, we have no way to measure cosmic consciousness, no instruments to detect a universal mind. It may remain a question forever wrapped in wonder and philosophy. As you slip into sleep, imagine the stars not just as burning spheres, but as neurons in a vast cosmic brain. A universe that listens, remembers, and maybe, even if only softly, dreams. 45. Are there dimensions beyond the ones we see? We live in a world of 3 spatial dimensions, up and down, left and right, forward and back, and one of time. But what if there are more dimensions, hidden just beyond our senses? This is not just science fiction, it's a serious idea in modern physics. Theories like string theory suggest the universe may have 10 or even 11 dimensions. These extra dimensions might be curled up so tightly that we can't see or touch them. Imagine trying to see a thin thread from far away. It looks like a line, but up close, it might have twists and loops you'd never notice without magnification. These hidden dimensions could help explain why gravity is weaker than other forces, or why particles behave the way they do. They may also be the bridge between quantum physics and the theory of relativity, 2 powerful ideas that haven't yet been united. Some even speculate that other dimensions could contain entire parallel worlds, layered next to ours but unreachable, like pages in a closed book. We may never travel to these dimensions, but their existence would mean our universe is more complex and more beautiful than we ever imagined. As you drift deeper into rest, imagine walking through a doorway that doesn't exist in our world, into a place with directions you've never known. A space of unseen motion, folded silently into everything. 46. What is the true size of the universe? When we gaze into the night sky, we see only a sliver of what's out there. The observable universe stretches about 93 billion light-years across, but that's just what light has had time to reach us since the Big Bang. Beyond that, the true size of the universe could be far greater, maybe even infinite. Because the universe is expanding, light from faraway galaxies hasn't had time to reach us yet. That means there could be entire regions, filled with stars, galaxies, even clusters, completely beyond our view. We're like a person on a small boat, looking out at a fog-covered sea, with no idea how far the ocean truly goes. Some theories suggest the universe may loop around on itself. If you could travel far enough in one direction, you might eventually return from the other side, like walking around a globe. Others believe it just stretches on endlessly, a flat plane of space with no edges, no boundaries, and no center. We may never know the full extent. Even our most powerful telescopes can't reach beyond the observable edge. The true size might remain one of the universe's best-kept secrets. As you slip into dreams, imagine floating at the edge of what's known, staring into a velvet sky that keeps going and going, silent, endless, and full of galaxies that may never be seen, but are out there just the same. 47. What are rotating black holes hiding? Most black holes aren't still. They spin, sometimes incredibly fast. These are known as rotating black holes, or Kerr black holes, and they're more than just cosmic drains. Their spinning nature might reveal secrets we've only begun to imagine. A rotating black hole doesn't just pull things in. It twists space-time itself around it, like a spoon stirring syrup. This creates a region outside the event horizon called the ergosphere, where nothing can stay still. If you were caught there, you'd be forced to spin along with the black hole, even if you weren't falling in. And here's where things get even stranger. Some theories suggest it might be possible to escape from a rotating black hole if you enter just right and use the spin to your advantage. There's even speculation that a spinning black hole could be a gateway linking to another region of space or even a different universe. Inside, the structure is different too. Rather than collapsing straight to a singularity, rotating black holes may have a ring-shaped core, a donut of infinite density where time and space collapse into something we can't describe. As you relax into sleep, picture a black hole not as a dead end, but as a swirling tunnel, silent, dark, and maybe open. A mystery wrapped in motion, spinning softly at the heart of the unknown. 48. Could there be life in the clouds of Venus? Venus is a planet of extremes. On its surface, temperatures are hot enough to melt lead, and the pressure is crushing. It seems like the last place you'd find life. But high above its deadly surface, in the thick clouds, there may be a different story. Roughly 30 to 40 miles up, Venus's atmosphere is surprisingly Earth-like. The temperature and pressure are more comfortable, and there's even a layer rich in sulfuric acid. It sounds harsh, but some Earth microbes can survive in acidic conditions. So, could something be alive in the skies of Venus? In 2020, astronomers detected a strange gas called phosphine in Venus's clouds. On Earth, phosphine is produced by bacteria in oxygen-poor environments. It's hard to make naturally, which led some to wonder, could this be a sign of floating microbial life? The discovery is still debated. The signal might have been a mistake, or caused by unknown chemical reactions. But the possibility opened a new door. Life doesn't have to live on the ground. It might drift in the air, feeding on sunlight, chemicals, or clouds. We're now considering future missions, balloons or aerial drones, to search Venus's skies more closely. As you drift into sleep, imagine quiet life forms, weightless and slow, gliding in golden clouds under a dim Sunday. If life can survive in the SK. 49. Why do some galaxies have no dark matter? Dark matter is supposed to be everywhere. It makes up most of the mass in the universe, silently holding galaxies together with its invisible gravity. But recently, astronomers found something strange: galaxies with almost no dark matter at all. That shouldn't be possible. Dark matter is thought to be essential for galaxy formation. It creates the gravitational scaffolding that gathers gas and dust, helping stars form and galaxies grow. Without it, everything should just drift apart. So how are these galaxies staying together? One possibility is that we're seeing galaxies that lost their dark matter. Maybe a close encounter with another galaxy stripped it away. Or perhaps they formed under unusual conditions, with more visible matter than expected. Even more puzzling, some galaxies appear to have only dark matter, barely any stars or gas, but lots of mass. These ghostly galaxies are nearly invisible, yet massive enough to warp light and influence others nearby. If some galaxies can form without dark matter, or with too much of it, our understanding of how galaxies grow, and what dark matter really is might need to change. As your breath deepens, imagine ghostly galaxies drifting through the night, some nearly empty, some overflowing with hidden force. Like celestial riddles written across the sky, these galaxies remind us that even what we think is everywhere might sometimes be missing. 50. Could wormholes be real? Imagine a tunnel through space, an invisible shortcut connecting two distant points in the universe. This is the idea of a wormhole, a passage through space-time that could, in theory, allow instant travel across galaxies or even time. But are wormholes real? Or are they just beautiful ideas written into the equations of physics? Wormholes are predicted by Einstein's theory of general relativity. If space can bend and curve, then maybe it can also fold, and where it folds, a tunnel might form. Think of a piece of paper with two dots far apart. Fold the paper so the dots touch, and you've created a shortcut, a wormhole. So far, we haven't found any. But some scientists believe wormholes could exist in the fabric of the cosmos. They might be tiny, smaller than atoms, or they could stretch across light years. The challenge is, wormholes would be unstable. They'd collapse the moment something tried to pass through, unless held open by exotic matter with negative energy, something we've never seen. Still, the math says it's possible. And the idea is too fascinating to ignore. Wormholes also raise strange questions. Could you travel back in time by passing through one? Could information, or even life, be using wormholes right now, beyond our view? As your mind softens into rest, imagine stepping through a silent doorway in space. No noise, no light, just a tunnel between stars, waiting patiently in the dark. A cosmic bridge, from somewhere to somewhere else. 51. What created the Great Attractor? Far beyond our galaxy lies something mysterious, something so massive, it's pulling entire clusters of galaxies toward it. This invisible force is called the Great Attractor. But what exactly is it? That remains one of the biggest questions in cosmic cartography. Galaxies aren't just floating in space randomly. They are moving, slowly but steadily, drawn by gravity. But when astronomers mapped the motions of galaxies in our region of the universe, they noticed something strange. Everything was being pulled in one direction. That direction pointed toward a dense part of the cosmos in the zone we call the zone of avoidance, a region obscured by the Milky Way's dust and stars. Behind that curtain lies the Great Attractor. At first, scientists thought it might be a massive cluster of galaxies. But even after mapping what they could, the pull remained stronger than expected. There might be something even larger, a structure called the Shapley supercluster, farther behind it, amplifying the attraction. And yet, no one really knows what it is. It's like the universe itself is leaning in one direction, pulled by an unseen hand. As your eyes grow heavy, imagine countless galaxies sliding through space, following a silent current they can't resist. A gravitational whisper from a hidden part of the universe, calling them home. 52. What are ultraluminous X-ray sources? Scattered across the cosmos are strange beacons, objects that shine with X-rays far brighter than a typical star, brighter even than small black holes. These are called ultraluminous X-ray sources, or ULXs, and they defy our understanding of what small cosmic objects can do. Normally, a black hole or neutron star shines in X-rays when it pulls in material from a nearby star. As the gas spirals inward, it heats up, releasing intense energy. But ULXs are different. They are too bright. They give off more X-rays than any normal-sized black hole should be able to. According to the physics we know, they should be tearing themselves apart, but they don't. So what are they? One possibility is that they are intermediate mass black holes, larger than stellar black holes, smaller than the supermassive ones. But these are incredibly rare and hard to find. Another idea is that ULXs are neutron stars with incredibly strong magnetic fields, known as magnetars, pulling in material at extraordinary rates. Some ULXs even pulse, like lighthouses, suggesting they are not black holes at all, but spinning neutron stars. That raises even more questions. How can such small objects shine with so much power? As you rest tonight, imagine a star-sized object glowing invisibly with X-rays, hidden from your eyes but burning in ways we still don't fully understand. ULXs are like cosmic lanterns, too bright, too strange, and too perfect to ignore. 53. Is the universe finely tuned for life? Look around, and you'll see a universe perfectly balanced for existence. The strength of gravity, the charge of electrons, the rate of expansion, all these values are set just right. Even the slightest difference would make life impossible. So, is the universe finely tuned for life? This mystery lies at the heart of science and philosophy. If gravity were just a bit stronger, stars might burn too fast. If weaker, they might never form. If the expansion of the universe had been slightly faster, galaxies couldn't have come together. The odds seem almost too perfect. There are several ideas. One is the anthropic principle. Maybe the universe has many possible forms, but we live in the one where life can exist, because otherwise, we wouldn't be here to wonder. Another idea is the multiverse, countless universes, each with different laws, where only a few, like ours, allow life to emerge. Or perhaps, some say, the universe was designed, not in a religious sense necessarily, but as part of some deeper cosmic logic we can't yet grasp. We don't have a final answer. But the more we learn, the more it seems the universe walks a razor-thin line between chaos and creation. As your mind softens into dreams, imagine the delicate balance of everything: stars, atoms, life, resting on invisible threads. The universe could have been anything, but it became this. And somehow, we are here to notice. 54. What are the origins of cosmic rays? Every second, invisible particles called cosmic rays rain down on Earth from space. They move at nearly the speed of light and carry immense energy. But where do they come from? What launches them across the universe with such force? Cosmic rays are mostly protons, with some electrons and atomic nuclei. They strike Earth's atmosphere constantly, creating showers of secondary particles that sometimes reach the ground. We've known about them for over a century, but their sources remain a mystery. Some cosmic rays come from the sun. Others likely come from supernovae, massive star explosions that fling debris across space. But the most energetic ones, the ones with power millions of times greater than anything we can produce on Earth, seem to come from far beyond our galaxy. Some theories point to active galaxies, quasars, or gamma-ray bursts as possible sources. These are some of the most violent environments in the cosmos, and they could act like natural particle accelerators. But we haven't yet found a smoking gun, a clear source that lines up with the arrival of ultra-high-energy cosmic rays. We also don't fully understand how they travel. Magnetic fields twist their paths, hiding their origins and making them almost impossible to trace. As you drift into rest, imagine particles born in ancient explosions, racing through the galaxy for millions of years, only to gently touch the Earth and you. Tiny messengers from distant stars, whispering of power and time. 55. Could gravitational waves reveal new physics? Gravitational waves are ripples in the fabric of space-time, created when massive objects like black holes collide. First predicted by Einstein in 1916, they were finally detected a century later in 2015, proof that space itself can stretch and shake like a sheet in the wind. But now that we've heard them, what else might they reveal? These waves are created during cataclysmic events, black holes merging, neutron stars crashing together. The energy released is enormous, and the waves they send out carry information about the masses, distances, and even the spin of these objects. But some scientists think gravitational waves could do more than confirm what we already know. They might help us discover new physics. Perhaps even reveal hidden dimensions or particles we've never detected. Unlike light, gravitational waves travel through space without being blocked or scattered. They give us a direct line into events that light can't escape. They may even carry information from the first moments after the Big Bang, farther back than any telescope could see. In the future, more sensitive detectors might uncover strange patterns or unexpected frequencies, clues that something is missing from our theories. As you fall deeper into sleep, imagine the universe humming softly, its vast body ringing like a bell. A quiet song of creation, carried across time and space, and still unfolding. 56. What is the universe expanding into? We know the universe is expanding. Galaxies are drifting apart, space itself is stretching. But this leads to a curious question: what is it expanding into? It's tempting to imagine space like a balloon inflating in a room, stretching into something bigger. But in cosmology, space isn't expanding into anything. Instead, it's space itself that's growing. The distances between galaxies increase, not because they are moving through space, but because space is unfolding between them. In simple terms, the universe doesn't need a surrounding container. According to general relativity, space can expand without anything outside it. The expansion is like a math-driven unfolding of geometry itself. Still, this concept can feel strange. How can something grow if it has no edges? No outside? Some theories, like higher dimensional space, propose that our universe might be a brain floating in a larger, unseen realm. If so, maybe there is an outside, and maybe the universe really is expanding into it. But that's still speculation. The truth is, when we ask what the universe is expanding into, we may be asking a question beyond current physics. As you settle into sleep, imagine the edges of the cosmos not as a wall, but as a horizon. A boundary of what we can know, with something silent beyond. Not emptiness. Not space. Just possibility. 57. What caused the cold spot in the cosmic microwave background? When we look into the deepest reaches of space, we see the afterglow of the Big Bang, a faint radiation called the cosmic microwave background, or CMB. It's nearly the same in all directions, smooth and uniform. But there's one region, one mysterious cold spot, that breaks the pattern. It's colder than it should be. And no one knows why. This cold spot isn't just a small difference. It spans hundreds of millions of light years across. Some scientists believe it could simply be a statistical fluke, just a random patch that happened to form that way. But others aren't so sure. One theory says the cold spot was caused by a massive supervoid, an enormous area of space with fewer galaxies and less matter. This void could stretch the light coming through it, making it appear colder. But even the biggest known voids don't seem large enough to explain the temperature drop. Another, more exotic idea? It might be a bruise from another universe. If our universe once collided with another bubble in a vast multiverse, it could have left a mark, an icy fingerprint in the sky. We don't have a final answer yet. As you float towards sleep, picture the ancient glow of creation, nearly perfect, but touched by one strange chill. A quiet reminder that even the most consistent patterns can hold secrets. 58. Are there shadows of other universes? We live in one universe, with its own stars, galaxies, and laws of physics. But what if ours is just one of many, an island in a vast multiverse? Could there be other universes, drifting alongside ours, and could we ever see their shadows? The idea of a multiverse comes from several areas of physics. Some versions of inflation theory, the rapid expansion that followed the Big Bang, suggest that our universe is just one bubble among countless others. Each bubble could have different physical constants, different particles, even different dimensions. But if other universes exist, how could we possibly detect them? Some scientists think collisions between universes might leave marks, like circular patterns or anomalies, in the cosmic microwave background. Others propose that gravity, which isn't bound by the same rules as light, could leak between universes, subtly shaping ours in detectable ways. So far, we found no concrete evidence. But the search continues. Because if we ever did see a trace, just one faint echo of a neighboring universe, it would change everything we know. As your thoughts begin to blur into dreams, imagine a sky not with one cosmos, but with infinite possibilities. Silent universes brushing against one another, unseen, unfelt, but always there. 59. Why does the universe have more matter than antimatter? When the universe was born, matter and antimatter should have been created in equal amounts. Every particle should have had a mirror twin with opposite charge. But somehow, there's more matter than antimatter today. Everything we see, stars, planets, people, shouldn't exist. And yet, we do. This imbalance is called the baryon asymmetry, and it's one of the most puzzling mysteries in cosmology. When matter and antimatter meet, they annihilate each other in a burst of pure energy. If the Big Bang created them equally, the entire universe should have ended in light. But something tipped the balance, just slightly, leaving behind a small excess of matter that became everything. Why? One idea is that, early on, particles and antiparticles didn't behave in exactly the same way. Tiny differences in their decay or interactions, called CP violation, might have created a preference for matter. Experiments have confirmed some CP violation, but not nearly enough to explain what we see. Other theories suggest exotic processes in the early universe, or interactions with unknown forces or particles, could have caused the imbalance. Still, the cause remains unknown. A cosmic mystery built into every atom. As you gently slip into rest, imagine a moment in time where balance was broken, just enough to allow stars to shine, planets to form, and life to exist. Out of symmetry came a tiny flaw. And from that flaw, everything. 60. What is dark flow? Most galaxies move in predictable ways, drifting apart with the expansion of the universe. But scientists have found something strange, a group of galaxy clusters all moving in the same direction, towards something outside the observable universe. This unexplained motion is called dark flow. It was discovered when astronomers studied the cosmic microwave background, the afterglow of the Big Bang. They noticed that certain galaxy clusters were all heading toward a particular region of the sky, moving faster than expected. Not just because of gravity from nearby structures, but as if being pulled by something far, far beyond what we can see. But what could cause this? One idea is that something massive lies outside the visible edge of the universe, perhaps a superstructure, or even another universe whose gravity is influencing ours. Another possibility is that we're seeing a relic effect from before inflation, when the universe was much smaller and more chaotic. Or maybe our current understanding of space-time just isn't complete. We don't yet know if dark flow is real or just a result of flawed data. Newer observations have challenged it, but the mystery remains. As your mind sinks into quiet, imagine entire galaxies pulled by an invisible current, sailing across the cosmos like leaves in a wind we cannot see. A cosmic tide, reaching in from beyond the horizon. 61. Are there particles faster than light? According to Einstein's theory of relativity, nothing can travel faster than light. Light speed is the universal limit, the cosmic speed cap that shapes how time and space behave. But what if there are particles that break the rules? Particles that move faster than light itself? These hypothetical particles are called tachyons. They haven't been observed, but they've captured the imagination of scientists and sci-fi fans alike. Tachyons would be unlike any known matter. If they existed, they could never slow down to light speed, only move faster than it. Time would behave differently for them, even flowing backward in certain frames of reference. Could tachyons be real? So far, there's no experimental evidence. But some versions of string theory and quantum field theory allow for particles that behave in bizarre, faster-than-light ways. Others argue tachyons are just mathematical ghosts, useful in equations, but not physically real. Still, the idea keeps popping up, especially when exploring concepts like time travel, quantum entanglement, or faster-than-light communication. As your eyes close and the night deepens, imagine a particle so swift it outruns light itself, dancing at the edge of causality, teasing the limits of what we think is possible. A traveler not just through space, but through time. 62. Could the universe have emerged from a black hole? We often imagine black holes as endings, points where stars die, where time stops, and where matter disappears. But what if a black hole isn't an end at all, but a beginning? Some scientists have proposed a stunning idea that our universe may have formed inside a black hole. That when a black hole forms in one universe, the core doesn't just collapse, it bounces, forming a new, expanding space-time on the other side. This theory arises from attempts to connect quantum mechanics with general relativity. In some models, the crushing force of a black hole singularity is avoided by a process called a quantum bounce. Instead of collapsing to a point, matter rebounds, triggering the birth of a new universe. From the outside, it looks like a black hole. From the inside, it becomes a cosmos. That means black holes in our universe might each contain their own baby universes. And ours may be one of many, born from the death of a massive star in some parent universe we'll never see. It's a deeply humbling idea that the end of one reality could plant the seed of another. As you drift deeper into sleep, imagine the swirling darkness of a black hole, not as a void, but as a cosmic womb, quiet, heavy, and waiting. A place where time folds in, and something entirely new unfolds on the other side. 63. Could sound exist in space? We often hear space described as silent. And in many ways, that's true. Sound, as we know it, needs air or water to travel, vibrations moving through a medium. Space, being mostly a vacuum, lacks that. So does that mean space is completely quiet? Not quite. While you wouldn't hear sound with your ears in space, the universe does have its own kind of music. Vibrations can travel through gas clouds, plasma, and even entire galaxies. These aren't sounds in the way we usually think of them, but they can still be detected and translated into something we can hear. Black holes, for example, can cause ripples in hot gas that behave like deep, low-frequency sound waves, far below what human ears can detect. In fact, the Perseus galaxy cluster has been recorded producing a B-flat note, 57 octaves below middle C. It's the deepest known sound in the universe. NASA and other space agencies have also used data sonification, turning signals from stars, galaxies, and even exoplanets into musical tones. These sounds aren't artificial, they are real data, converted into a language we can experience. So, while space doesn't sing in air, it hums through gravity, pulses through energy, and echoes in frequencies we're only just beginning to hear. As you settle into sleep, imagine the silent music of the cosmos, so low, so vast, it plays not to ears, but to the imagination. A lullaby written in the very structure of the stars. 64. Are there planets with eternal night? On Earth, we take day and night for granted. But in some corners of the galaxy, there may be planets where the sun never rises or never sets. These are tidally locked planets, worlds that always show the same face to their star, just as the moon always shows one face to Earth. On a tidally locked planet, one side would be in perpetual daylight, scorching and sunlit forever, while the other side would be trapped in eternal night, frozen in darkness. Between them would lie a narrow twilight zone, a band of perpetual dusk, perhaps the only habitable region. These planets aren't rare. Many exoplanets found orbiting red dwarf stars, some of the most common stars in the universe, are likely tidally locked. Scientists now believe that life could still exist on such planets, adapted to the harsh split between light and dark. What would it be like to live on a world where the stars never move? Where one horizon always glows, and the other always hides? Would creatures evolve to thrive in the dark, never knowing daylight? Would civilizations rise under fixed constellations, never seeing a sunrise? As your thoughts begin to dim, imagine standing on the night side of such a planet, stars frozen overhead, silence all around. A land of shadows, untouched by time, where darkness is not the absence of light, but a world all its own. 65. What happens at the edge of the observable universe? The observable universe stretches as far as light has had time to reach us since the Big Bang, about 46 billion light-years in all directions. But what lies beyond that? What happens at the edge of what we can see? It's not a hard wall. There's no barrier or edge in the usual sense. Instead, it's a horizon, a limit set by time and the speed of light. We simply can't observe anything beyond it, because light from those regions hasn't had enough time to reach us yet. Still, the universe doesn't stop there. It likely continues far beyond the observable edge, possibly forever. There could be galaxies, stars, and even entire structures stretching into the unseen. What's truly fascinating is that those distant regions are also seeing their own observable universes centered around them. Each observer has a different view of the cosmos, shaped by where they stand and how long light has had to travel. And what we see now from the edge? That light left billions of years ago. Some of the galaxies we observe at the limit may no longer exist. They've changed, collided, or disappeared, but their light is only now arriving. As you drift off, imagine gazing out from a cosmic balcony, watching the faint, ancient light of galaxies that no longer are. At the edge of the known lies not darkness, but history, time, and the infinite possibilities beyond sight. 66. Could alien probes already be in our solar system? When we think of alien life, we often imagine distant planets, radio signals, or giant ships arriving from far-off stars. But some scientists have proposed a quieter possibility. What if alien probes are already here, drifting silently in our solar system unnoticed? This idea is known as the lurker hypothesis. The theory suggests that an advanced civilization might send small, self-replicating probes to explore the galaxy, machines designed to hide, observe, and gather information. These probes wouldn't need to announce themselves. They'd simply wait and watch. With billions of stars and planets, visiting each one directly would take forever. But tiny probes, scattered like seeds, could travel much faster and farther than any living beings. They could perch on asteroids, moons, or even float in deep space, using solar power or tapping into alien technologies we can't imagine. Some have speculated that objects like Oumuamua, an interstellar visitor detected in 2017, might have been a probe. It had strange characteristics: no visible tail, odd motion, and unusual speed. Most likely, it was natural. But still, it made us wonder. Could something be here already, hiding in plain sight? Not dangerous. Not interfering. Just watching, waiting, and learning? As your breath slows, imagine a quiet machine, tucked away in the shadows of the moon or resting deep within the asteroid belt, silent, ancient, and curious. Not a threat, but a witness. A messenger from minds far beyond our own. 67. Why do some stars just disappear? Across the sky, stars are born, live for billions of years, and eventually fade away or explode. But recently, astronomers have noticed something stranger. Some stars simply vanish. One day they are visible, and the next, they are gone. This mystery came to light when scientists compared old telescope images with newer ones. In a few cases, a bright star that once appeared clearly in the sky had disappeared completely, without a supernova or explosion to mark its end. How could a star vanish without a trace? One possibility is that some stars collapse directly into black holes. Normally, when a massive star dies, it explodes in a brilliant supernova. But maybe, in some rare cases, a star skips the explosion and implodes quietly, becoming a black hole without any warning flash. Another idea is that these missing stars were never stars at all. Maybe they were flaring objects like quasars or even errors in the data. But the fact that multiple cases exist suggests something real is happening. Could it be a new kind of stellar death? Or a sign of processes we haven't yet understood? As you settle deeper into rest, picture a star glowing steadily in the night, and then gently winking out, like a breath held in the dark. Gone not with a bang, but a silence so perfect it leaves only questions behind. 68. Are we living in a false vacuum? The universe feels stable. Stars shine, planets orbit, and time flows forward. But some physicists believe our universe might be in a false vacuum, a delicate, temporary state that only appears stable until it suddenly isn't. To understand this, imagine a ball resting in a shallow dip on a hill. It looks stable, but a deeper valley lies just beyond. One small push, and the ball rolls down, into a new, lower energy state. That's what a false vacuum is, a universe balanced in a temporary minimum, with a deeper, true vacuum lurking beyond. If our universe is indeed in a false vacuum, then a quantum event, one that could happen without warning, might trigger a phase transition. A bubble of true vacuum would form and expand at the speed of light, rewriting the laws of physics in its path. Time, space, matter, everything would change instantly. There'd be no warning, no escape. It sounds terrifying, but there's no reason to worry. If it ever happened, we wouldn't even see it coming. And the odds? Vanishingly small, so small, they're not even measurable. Still, the concept fascinates physicists because it reminds us that reality itself may be stranger than we know. Even the vacuum of space isn't truly empty. It holds secrets of energy and structure deeper than our senses can grasp. As your body softens into sleep, imagine the universe as a still pond, calm on the surface, but hiding something deeper beneath. A balance so perfect, it almost hums. 69. Could there be life in interstellar space? We often imagine life growing on warm planets, orbiting stars, bathed in light. But what if life exists in the cold, empty space between the stars? Could something survive, and even thrive, in the vast stretches of darkness we call interstellar space? It seems unlikely. This region is freezing, nearly a perfect vacuum, with little more than scattered atoms, dust, and radiation. But space isn't truly empty. Complex molecules, including the building blocks of life, have been found floating between stars. Some of these compounds even resemble amino acids, the very chemicals that form proteins. Some scientists propose that hardy life forms, perhaps microscopic and deeply alien, could travel through space aboard dust particles, meteors, or icy comets. This idea is known as panspermia, life spreading through the cosmos like spores in the wind. Could these tiny travelers drift for millions of years, frozen in time, only to awaken when they land somewhere warm and welcoming? Others speculate that entirely new forms of life could exist in space itself, based not on carbon and water, but on plasma, electromagnetic fields, or something beyond our current science. As you drift into sleep, imagine tiny life forms hidden within comets, sailing slowly through the dark, enduring, waiting, dreaming of stars. The space between worlds may not be empty at all, but alive with mystery. 70. What caused the Great Silence? If the universe is filled with stars and planets, and perhaps even civilizations, then where is everyone? This is the famous Fermi paradox, the contradiction between the high probability of alien life and the complete absence of contact. It's sometimes called the Great Silence. There are hundreds of billions of galaxies, each with billions of stars. Many of those stars have planets, and some of those planets could support life. So statistically, intelligent life should have emerged many times. And yet, no signals, no messages, no visits. Why? Maybe intelligent life is incredibly rare or short-lived. Civilizations might destroy themselves before they can reach out to the stars. Or maybe they choose to remain silent, watching but never speaking. Some think we might be in a sort of cosmic zoo, observed, but intentionally left undisturbed. Others suggest we're simply too early or too late to find others. Maybe the galaxy is full of voices, but we're listening at the wrong time or in the wrong way. Or perhaps we're the first. As you drift off, imagine the quiet night sky above, not empty, but full of potential. Each star a question, each silence a whisper. Maybe the universe isn't ignoring us. Maybe it's just waiting. 71. Is our universe a hologram? It sounds like science fiction, but it's a real theory in physics. What if our entire universe is a hologram? A three-dimensional illusion, projected from information encoded on a distant, two-dimensional boundary? This idea, called the holographic principle, arises from attempts to understand black holes. When matter falls into a black hole, its information seems to vanish. But physics says information can't be destroyed. So where does it go? Some scientists believe the information is stored not inside the black hole, but on its surface, like a hologram. This led to a bold question. If this applies to black holes, could it apply to the whole universe? According to this theory, everything you experience, space, time, even your body, might be the result of data encoded on a vast cosmic screen far away. Just like a hologram, which appears three-dimensional but comes from a flat image. If true, it would mean reality isn't what it seems. The laws of physics, the shape of space, even gravity itself could emerge from a deeper layer of existence we can't see. But don't worry, it doesn't make life any less real. Just more mysterious. As your eyes close, imagine the stars above not as distant points, but as flickers of something deeper, patterns on a cosmic film, casting a quiet illusion so perfect, we call it reality. 72. Could the laws of physics be different elsewhere? Here on Earth, and as far as we can observe, the universe follows specific rules. Gravity pulls, light travels at a constant speed, and particles behave according to quantum laws. But what if, somewhere far beyond what we can see, the rules are different? This isn't just a fantasy, it's a serious possibility in theoretical physics. Some versions of the multiverse theory suggest that each universe could have its own unique set of physical constants. In one universe, gravity might be stronger. In another, atoms might not even form. Some universes might have no light, no time, or no structure at all. Even within our own universe, some have wondered, are these constants really constant? Could they shift slowly over time, or vary in distant regions we haven't yet reached? If the laws are local, shaped by cosmic events or fields we don't yet understand, then reality itself might not be as fixed as it seems. But why do our laws allow for stars, planets, and life? Is it coincidence, or something deeper? As you settle in, imagine distant realms where light bends differently, time ticks in reverse, or matter never takes shape. Other realities, shaped by other rules. And in this quiet corner of the cosmos, we just happen to be in the version where everything fits. 73. What is the source of fast radio bursts? In the stillness of space, brief, powerful flashes of radio energy burst into existence and vanish in milliseconds. These are called fast radio bursts, or FRBs, and they are one of the most puzzling phenomena in astronomy today. The first FRB was discovered in 2007. Since then, hundreds more have been detected, some only once, others repeating in mysterious patterns. They come from far outside our galaxy, sometimes billions of light-years away, and yet they carry more energy in a split second than our sun produces in days. What could cause such an intense and fleeting signal? Some FRBs may come from magnetars, a type of neutron star with a magnetic field 1 trillion times stronger than Earth's. Others might result from collisions between stars, or even from the collapse of exotic cosmic objects. But the mystery deepens. A few FRBs repeat, but not in predictable ways. Some come from strange galaxies. Others come from the outskirts of nowhere. A few scientists have even speculated that FRBs could be artificial, perhaps beacons or signals from advanced civilizations. It's a fringe idea, but the universe leaves room for wonder. As you ease into sleep, imagine the galaxy whispering, sharp, sudden flashes like Morse code across the void. Signals from somewhere. Maybe natural. Maybe not. But always sudden. Always brief. Like lightning in the cosmic dark. 74. Why is the universe so uniform? When we look at the universe on a large scale, we see something surprising. It's incredibly uniform. No matter which direction we look, galaxies are spread out evenly. The cosmic microwave background, the light from the early universe, is nearly the same temperature everywhere. But how did everything become so balanced? This puzzle is called the horizon problem. Regions of the universe that are now billions of light-years apart shouldn't have had time to communicate in the early moments after the Big Bang. And yet, they look almost identical, as if they started out in perfect coordination. The most accepted explanation is cosmic inflation, a burst of faster-than-light expansion that happened a tiny fraction of a second after the Big Bang. This would have stretched the early universe out smoothly, ironing out irregularities like a balloon inflating evenly. But even inflation raises new questions. What caused it? Why did it start? And why did it stop? Is it still happening somewhere else, creating new universes beyond our own? No one knows for sure. But what's clear is that the universe we see is remarkably even, calm, and structured against all odds. As your thoughts begin to fade, imagine the entire cosmos expanding in slow, even rhythm. Balanced. Smooth. A vast, quiet breath, held for billions of years. 75. What existed before the Big Bang? The Big Bang is where our story begins, or so we're told. It marks the birth of time, space, matter, and energy. But one question lingers like a soft echo: what came before? This is one of the deepest mysteries in all of science and philosophy. According to standard physics, time itself began with the Big Bang. That means asking what happened before is like asking what's north of the North Pole. It doesn't quite make sense in the way we're used to thinking. Still, many scientists and thinkers have dared to explore the possibilities. Some propose that the universe cycles endlessly, expanding, collapsing, and being reborn in an eternal loop. Others suggest a quantum foam, a seething chaos of energy, existed before our universe took form, bubbling into the cosmos we know. Some believe the Big Bang wasn't the beginning at all, but a bounce, our universe emerging from the death of a previous one. Then there are theories involving higher dimensions, timeless states of existence, or even multiple universes birthing one another across realities we can't yet detect. But perhaps the most humbling idea is that we may never know. That the origin of everything is hidden behind a veil we cannot lift, not yet. As your mind floats gently into sleep, imagine the moment before time, a silence before the first heartbeat of reality. Not darkness, not light, just possibility. The universe has told us many stories, but some questions are so deep they are meant to be dreamed.